Today is the first day of the rest of our lives. And happy spring to our space weather viewers. Congratulations on realizing the Smash News Network least busted name in news exists. We just bring you the most detailed solar imagery and comprehensive space weather in the world. No big deal. I mean, nothing to see here, folks. Except, well, we've got a new sunspot. We've got lots of stuff to talk about. Lots of solar features. Another solar uptick continues. Expect another increase in the sunspot number, the radio flux, and the solar flaring. Let's take a brief look at some features here, like this massive prominence over here in the western equatorial region. That's pretty sweet. Putting some oohs and ahs in the early portion of the video. Don't forget about what's going on in the southern hemisphere. Lots of stuff going on down there. A massive series of sunspots over here in the southeast. South central, a massive coronal hole. And over here, a rapidly forming new sunspot. Increases the probability that we'll see a significant solar flare from over here in the southwestern limb. So a prime example there of how the magnetic environment can suddenly change. A sunspot forming rapidly there in the southwest. Here's this gigantic group of sunspots containing probably over 100 umbrae. These are all 24-hour videos, by the way, in 304 plus 193 angstroms from the SDO. It's the ultraviolet emissions from ionized helium and ionized iron. Also, a massive filament up here continues to be right in the Earth-facing portion of the solar disk. Check out this filament. We've been naming them after living people, and one of our viewers has named this filament the Gene Simmons. It looks like it might have gotten a little bit unstable, but it appears to still be intact for the most part. So that's one to keep an eye on. And when I say eye on, pardon the pun. Let's take a look at sunspots here. This is yesterday plus today. And this sunspot here is indeed massive, larger than the Earth. We've got like 3 or 4 sunspots that are larger than planet Earth right now. And yeah, keep an eye on this area right here as that rapidly growing sunspot group is approaching the limb, the most likely place to see a major solar flare. Don't be confused by the size of a sunspot. It's really the magnetic complexity, not the size, that determines the likelihood of a given sunspot producing flares. Let's take a look at Croissant Earth here for a minute. Nevado de Ruiz exploded in a fairly spectacular fashion there. We'll get to it. Here's the rest of your list, starting out with Shiveluch. These are the volcanoes from the past 24 hours. Shiveluch is producing a 20,000-foot ash plume over Kamchatka. It's a flight level 200. Flight level 100 over Abiko. Luatolo now back on the list here. Flight level 060, 6,000-foot ash plume over Luatolo. Semeru exploding. Flight level 150 over Semeru. 15,000-foot ash plume over East Java. Halmahera featuring a 7,000-foot ash plume as Tocono explodes. Popocatépetl exploding. Flight level 230, it's a 23,000-foot ash plume over central Mexico. Popocatépetl is probably my top bucket list volcano. Santiaguito exploding. 14,000-foot ash plume over Guatemala. 15,000-foot ash plume over Guatemala from Fuego as it explodes. Nevado de Ruiz, which is the picture we featured kicking off this segment, located in Colombia, producing a 21,000-foot plume of volcanic ash, a gray ash column. It did reach 26,000 feet there for a moment. And that increasingly larger plume was visible from Caldas, Tolima, and Risaralda. The alert remains at yellow, which is a good reminder to not necessarily trust alert systems. How can a volcano producing a 21,000-foot ash plume remain at yellow? Is that not a serious eruption in their mind? Sangay exploding, flight level 200 over Ecuador from Sangay, 15,000-foot ash plume over Revenador, as Revenador explodes in that same nation. Last but not least, Sabancaya exploding in Peru. Sporadic puffs produced a 24,000-foot ash plume, flight level 240. Global seismicity has been calm over the past 24 hours. Only a couple of quakes here over a 5 magnitude. There's your 90-day bar graph from Volcano Discovery. Let's scroll up the list here. So we did have a 5.1 at the South Sandwich Islands around 12 noon Universal Time yesterday. Interesting quake there on the west coast of Greenland. That's a very uncommon spot for a quake within the Arctic Circle, and that location there, not a common spot for earthquakes. The largest quake of the past 24 was a 5.5 at Costa Rica. That came through at 1:44 Universal Time this morning. Taiwan had a 5.2 practically at the same time there. Only a minute and 8 seconds later, folks. A 5.5 at Costa Rica and then a 5.2 at Taiwan almost simultaneously on the opposite sides of the Pacific. What does that do for your standing waves theory, by the way? You know, for those of you who watch Dutch Synths, he shows this idiotic video constantly about standing waves in a wave generator, and then he tells people that the universe is electric and that everything's connected. What a pile of crap. Dutch Synths. People still think that he forecasts earthquakes. So ridiculous. Standing waves. Standing waves. People think standing waves are magic. They think quantum mechanics. They think quantum field theory is magic, and they think electricity is magic, and plasma is magic, and magnets are magic, and they just aren't. Let's get back to space. And stop talking about how idiotic Dutch Synths is with his electric universe claims and idiotic ideas about standing waves being responsible for earthquakes. So silly and pathetic. Take physics. Please take physics. Here's the past 24 hours of SDO 171 angstroms. And let's add 304 angstroms for some additional contrast. Because nothing makes your ionized iron look better than some ionized helium. So I still think the Gene Simmons filament here is getting a little bit unstable at this end, as filaments tend to be anchored at their ends. And of course, you know, something to realize is that there's material going back and forth around this filament, almost like alternating current. Because the universe is not electric, however, certain parts of it are, like the solar corona and chromosphere. They're highly electric. Anyway, the 10.7 centimeter radial flux is now up to 156 solar flux units, and you can expect a precipitous increase in this in the coming days. I mean, short of those sunspots in the southeast suddenly evaporating, which is highly unlikely, expect a major uptick in the radial flux. I'm expecting this to be up at 180 within 36 hours. Also expect the sunspot number to increase to about 165, 170 in the next 24 to 36 hours, as sometimes it takes a while for those sunspots to get added to the sunspot number. But anyway, expect it to go up. And looking at the Space Weather Enthusiast dashboard here, we are expecting a CME impact really at any moment here. We do see a little uptick in some solar wind parameters. We'll get to it in a moment. We have passed the NOAA point of likely geomagnetic unrest. So NOAA forecasted a KP4 here a few hours ago. We didn't see that come through, but maybe that CME was a little bit slower than we forecasted. Don't you find it interesting that we forecasted it to arrive midday today, and NOAA forecasted it to arrive just 3 hours earlier? That's probably not a coincidence at all, folks. It's called accurate forecasting. By the way, quick side note, if you haven't checked out the merch, check out the merch shop. You can visit the link below the video to find the merch. It's very high quality and high resolution, and this is one of my favorite designs because it took a lot of effort to create this design. Creating a croissant-shaped Earth was less than easy, let's just say. And of course, we're making fun of various different things here. People think that NASA is perpetuating this idea of a spherical planet and things. And of course, there is a reason why we are stating that the Earth is croissant-shaped, which we'll get to here right afterwards. Again, visit the links below the video to help support the channel if you like. The merch is quite amusing to some, perhaps quite offensive to others, as a lot of people remain offended in 2023 by facts. Anyway, if you look at Earth's magnetic moment from space on the meridional planar view, doesn't it look a little bit croissant-shaped? I mean, you see what I'm saying here, folks? When a solar proton encounters Earth's magnetic moment from space, Earth is indeed croissant-shaped. So here's the past 4 hours of Earth's magnetic moment from space. We'll let this play through again, just to let that sink in. Because to quote Seinfeld, it's funny because it's real. So fairly steady here. I don't see any evidence of a proper glancing blow coronal mass ejection impact yet. So maybe it's just moving a little bit slower than expected. That is a thing that happens. I mean, we do guess when we suggest when CME impacts will happen. Now, we do have some magnetic perturbations on the ground level. So we showed you Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. So we'd like to show the North American zoom in here when we do see activity to give the maximum resolution to our viewers there. The most likely places to see things like pipeline, railway, power grid induction, also the aurorae, and telluric currents, also likely to be shown here by the space weather modeling framework. Here are global geomagnetic ground magnetic perturbations. The scale depicted on these images are, the units depicted on these images are in nanotesla, that's magnetic flux density. So a little bit of activity there, and we'll have a little more detail when we look at the real-time solar wind to see if anything is likely showing up. First, the KP index, which is at 2. Planetary K index is a measurement of global geomagnetism. It's an average of the entire planet, hence the term planetary K index. And let's take a look at the measurements taken at Lagrangian point 1 outside Earth's magnetosphere. And there is some data. Now we are seeing a little bit of an uptick here in the solar wind velocity. Not so much the density. A tiny uptick in the solar wind plasma temperature. A recent shift in the phi angle. It was quite minor. So, I mean, this could be a CME impact right here. And if that's the case, NOAA got it exactly right. I mean, you see this little shift in the magnetic field, a little shift in the phi angle, and a little increase in the solar wind speed. I mean, that could be the CME. If so, that's a really weak blow. I suspect that we'll see a better signal than this. Current conditions are about 450 kilometers per second for the solar wind velocity. Solar wind density, just under 8 protons per cubic centimeter. Next, some magnetic data. So here are your GOES magnetometers. Those are actual magnetometers measuring part of the Earth's magnetic field there from their geosynchronous near equatorial orbits. We see a little divergence happening here around midnight local time for the GOES 18. The GOES 16 picking up some higher readings as the GOES 18 picking up some lower readings. And let's take a look at the heliospheric current sheet next. These are differently obtained measurements here. These are using polarimeters. And the data comes from 51 ground-based magnetometers and one's on stereo A and stereo B. So that's stereo A there, represented by that little plus sign, and that's stereo B over there. Earth is solidly in a south pole current sheet. No likely changes to that coming anytime soon. I would also note that as you watch this video play, you're going to see a bunch of magnetism leaving the North Pole. So we are getting closer and closer to solar maximum here, or something that can be logically explained as solar maximum. Check it out. You see some North Polar fields shrinking there. So if you look at the first image, you can see there's quite a lot of solid green there at the north. That's the North Pole, the North Heliographic Pole. And if you look at the last image, a lot less. So that is part of the solar polar field reversal process. Let's take a look at our line of sight plot. Keep in mind these are 4 days 4 days depicted here. And let's move to coronal holes. And we've got some growth happening of this coronal hole. So that's another interesting thing here. This well-defined coronal hole here has grown since yesterday. And you may see some of that happening. So as you know, we can expect to watch this thing migrate possibly to the north. And it looks like it's actually happening there. You can see some additional holy area there opening to its northeast. So plasma gets redistributed. The coronal fields start to move around. That is what you call a solar cycle. Anyway, that brings us to sunspots, another rather important feature. We don't get fixated on that or anything else because we want to view the whole. We're interested in the physics of how things actually work. Plausible explanations. So first of all, this sunspot down here will get a name. That'll be 3261. And there may be some more named groups back here behind 3260 also. Also a likely named group or two here. So again, expect an increase in the sunspot number and the radio flux in the coming days. Let's take a look at sunspots here from some more SDO 24-hour videos. There's 171 plus SDO continuum. And let's get rid of the 171 angstroms and zoom in. So again, eyes on the southwestern limb as there could be a significant solar flare, perhaps even of an X-class variety coming from down there. This sunspot group here doesn't appear to be named yet, so that one should get a name. And there might be a new sunspot back here. So again, expecting an uptick in the sunspot number today, possibly another named group forming up here in the north. So plenty of stuff going on. If you were worried about the sun shutting down, just stop. It's ridiculous. It's ridiculous and absurd. And let's get to energetic particles and flares. So we do have some relativistic particles continuing to hang out, mainly around the polar regions, as those protons orbit Earth's magnetic field lines. And of course, they emit radiation, which is measured by the GOES 16, which is what you can see here. Let's look at solar flares next. And frankly, all the sunspots that we see currently are underperforming. We're seeing a surprisingly low number of flares. So it could be the calm before the storm, folks. Don't be surprised to see this make it way up here into the X-flare variety. Here's one of the better wavelengths to view flares, 131 angstroms along with 171 angstroms. And let's switch to 94 angstroms. Again, flares have been underperforming here for the number of sunspots and the magnetic complexity of those sunspots. So there is certainly the potential to see some major activity kicking off. And I mean, also watch this area south of the Gene Simmons filament right here, because that has been looking like some activity has been going on there. And let's move to a star chart. So, of course, we encourage our viewers to look up. The sun has not risen yet here over Lehigh Valley, PA. But if you're out there, you might be able to see Saturn yet, despite the sky starting to get light. Saturn is a pretty bright object up there. It's like the fifth or sixth brightest object in the sky. Here's your solar system forecast as we approach new moon. We're only a day out, I think. Here's your 1 week forecast from the lonely side of the solar system. The side Earth is on, devoid of gas giants. Keep in mind this imagery is not to scale. And yes, all the planets in the solar system orbit the gravitational point of the solar system called the barycenter. So the sun orbits the barycenter. It wobbles back and forth a little bit. And so do all the planets. So they are orbiting the sun, but the sun is also orbiting the gravitational point of the solar system. Anyway, here's your 1 week forecast. There's where things will be in a week. We've got nearly vertical Earth shadows, which we'll show you here in the meteorology segment. First, let's look at coronagraphs, as there have been some coronal mass ejections. So there is yesterday's 125 frames. And you're probably wondering if any of those are earthly directed. We'll show a breakdown in just a moment. Here are today's additional 8 frames there. That's not going to do us a lot of good, so let's take a look at Stereo A and the Soho Lasco C2 this time. So we've paused these at just after 1500 yesterday. So 1500 universal time there. You can see actually 2 different events happening at the same time, and neither of those are earthly directed. So one is off to the northeast, one is off to the southwest, and that other one is off to the northeast. So nothing major going on there, no Earth-directed coronal mass ejections. There's some imagery, 24-hour videos there featuring Mercury. Let's zoom all the way in here. So there's the full zoom. And let's look at filaments from the ground-based solar observatory at El Teide, Spain. So, I mean, this giant filament up here, that is the Gene Simmons filament. And, yeah, that is one to keep an eye on. Also, this prominence over here, but that's unlikely to produce anything earthly directed. The Gene Simmons filament is pretty much right in your face right now. It's pointing directly toward Earth. If you've got filaments you'd like to name, like perhaps this one here or maybe this one down here, join us over on Twitter. We are still shadow banned, if you're wondering. And Elon has not done jack to fix free speech on the internet. He just basically complained about it, exposed it, and then didn't fix it. Great idea, by the way. If you want some free mushroom gummies, because you want to try them out, you can find the Hemp Lucid link right there on the page. While supplies last, you got to pay shipping, but while supplies last, you can try out the mushroom gummies for stress, focus, sleep, etc. So check that out. Let's look at let's get current here and look at the past couple of hours from the Go 16 SUVi. So a little flare happening there, a decent sized flare actually, right there, from a region that doesn't even look like it's a sunspot, and also some, looks like a possible CME erupting right down here. So there's some stuff going on. Looks like an interesting start to the spring season for the Northern Hemisphere. Here's the past 24 hours in higher resolution and a lower field of view. The SDO, which is, I think, remaining my favorite telescope. Give us a couple years. Maybe we'll start liking the James Webb more, but at the moment, the SDO is where it's at. So let's get the bonus features here. First, satellite charging hazards from the satellite's community dashboard, and we are seeing some minor surface charging hazards here over the central Pacific, well, over the eastern Pacific. Moving toward the central Pacific, the GOES electron flux here is, looks like it cratered a little bit there, so that could also support a minor CME impact. We were expecting this to be a little bit higher. Let's check and see what the forecast is. And there's the forecast. NOAA was almost right on with that. The green boxes are the forecast. The yellow diamonds are the observation. There's the one-year chart to put that in context. Just low to moderate levels of relativistic electrons at the moment. And those are measured at the F layer of the ionosphere. So let's look at the vibrational frequency of that bridge between Earth and space. So here's the ionosphere, courtesy of Australian Government Bureau of Meteorology, if you want to follow this yourself. Here's the anomalygram. If you're unfamiliar looking at the raw vibrational frequency, this might give you a little bit of insight into what's going on. It also provides higher resolution, 10 times the resolution, in fact, as this shows down to 1/10 of a megahertz. Are things looking less anomalously than they did in the past few days? See our previous daily space weather videos for details. We show this data daily. And there's the latest image, 11 o'clock Universal Time. And there's the 11 o'clock anomalygram. We'll also show the total electron content forecast, which is the likely places to see GPS errors. Where there is high electron contents, there is a high likelihood of signal refraction, which can cause GPS errors of thousands of miles. And here's our total electron content forecast section. Things are actually quite orderly here, as we covered weeks and weeks of extremely anomalous total electron contents. And guess how many natural disasters were associated with that? Basically zero. It didn't forecast any large earthquakes, if you're wondering. We showed like 6 weeks of incredibly anomalous total electron content forecasts maybe a month and a half ago, and it didn't do jack. There were electrons all over the place. And precisely nothing happened. Here's our total electron content anomaly. This is the anomaly from the 10-day average over just North America. So there are some significant high electron flux anomalies there over places like Baja California once again. Southern California, Baja California, Western Mexico, and then here's just the U.S. Actually, it's still most of North America. That's our electron content anomalies. Low electron count anomalies are in blue. High electron count anomalies are in red. Last but not least, let's look at our latest images of El Sol. So first let's check up here. Indeed, that should be 2 new sunspot groups. There are 2 new sunspot groups there to be named. This one here doesn't have a name yet. I'm not even sure if that one has a name. I think that one has a name. Yeah. And then, of course, this area is just berserk. Here are the magnetic fields. Those are somewhat magnetically complex. This one here is beta gamma delta class. Anyway, there's your full disk rock back. It's time to get to meteorology. We'd like to include the meteorology segments in our space weather content videos because, well, analytics. When we compartmentalize our videos and we put them all into different smaller sections, guess what happened? We got less views. So the algorithm is just falling all over itself on YouTube. It has no idea what it's doing. It's complete junkware. It's utterly broken, like the hashtag system on all social media. It's a complete joke. And so in order to prevent us getting less views, we're making these videos in their full-length glory. It suggests that people are watching less content on YouTube because they're more interested in watching a 40-minute video than they are in watching a 4-minute video. So I found that interesting. What about you? And welcome to spring. We're just this side of 14 hours into spring. And what are your exciting plans? Let us know in the comments. By the way, if you enjoy the content, help support the channel by visiting our links. And welcome to the Neo Renaissance. Smashomash.com is the homepage. You can find links to Hemp Lucid. Don't forget to enter the promo code SMASHOMASH to save some dough on your checkout, or shop via the link right there on the homepage, or both. links to the merch shop, the YouTube channel, Twitter, Instagram, etc. If you want some motivation about athletic endeavors, join us over on Instagram. Again, Hemp Lucid. Save some cash by using our link or entering the promo code SMASHOMASH on checkout. Shop by Solutions, CBDs, mushroom gummies, immune stack, and lots more. If you want to support the channel via a subscription, consider becoming a member of the Smash Team at smashomash.com/Smash Team. Thanks to our Gold Smash Team members for contributing to the writing of our paper explaining plausibly the sunspot cycles. It's, shall we say, sort of important. And we've already informed our Gold Smash Team members of what the likely mechanism is that drives the solar sunspot cycles. If you'd like an @smashomash.com email address, most first names are still not taken. If you want like Steve at smashomash.com, we've got that covered. If you want Pierre Marie at smashomash.com, we've got that covered. So support the channel that way. There's a bronze level, there's a silver level, there's a gold level, and there's a gold annual paid-up subscription, which is the best value as it includes complimentary merch. And let's move to the realm of meteorology. So we're looking at a bunch of cold air here descending deep, deep into the southeastern U.S. So some anomalously cold air there. We're looking at temperature and surface winds. So the animated portion is the surface wind animation, and the shaded portion, the colored shaded portion there, is the temperature. And let's see what the coldest place in the world is. Coldest place in the northern hemisphere is currently Greenland, boasting temperatures below 50 degrees Fahrenheit, below zero. I'll say below negative 50 degrees Fahrenheit. And the actual coldest place in the world is indeed Antarctica. So near the South Pole there, 74.6 degrees Fahrenheit. Autumn is starting out on the cool side on the world's highest and driest continent. Yeah, it's drier than the Gobi Desert because, water doesn't like to be hanging around in air that's that cold. Anyway, here are the wind patterns of the eastern world. These are the jet streams, otherwise known as the 250 hectopascal winds. Very incoherent jet stream over Australia at the moment. Tripled up jet stream over Eastern Asia. Oops, I almost forgot surface winds. There are the surface winds like sands through the hourglass of time. These are the surface winds of the first day of spring for these people. And the first day of autumn, the first full day of autumn for these crazy lunatics living below the surface with water swirling down the drain clockwise instead of counterclockwise. It's berserk. And here are the surface winds of the Americas. The North Atlantic continues to be windy and not hospitable for seafaring. There are the jet streams of the Western world, jet streams of the Central world depicted here. Europe, Africa, and the Middle East, they've also got surface winds depicted here. So let's continue on and take a look at the Himawari satellite. Why? Because we've got the lines here. The shadows on the planet, look at how they're almost perfectly vertical, folks. You see that? See the way the shadow is vertical? That's called an equinox. The equinox is the point where Earth's equator crosses the sun's equator. Hence the axial tilt. The axial tilt causes very similar day-night cycles for the entire planet. And we're taking the sun back from you Southern Hemisphere types. Next to your weather.gov map, if your location's lit, click your location. There are too many counties and seaways for us to cover here. It looks like some high surf conditions around Hawaii. Weather.gov, once again, is the location of the National Weather Service map that we're showing. And let's do some forecasts. Here's our temperature anomaly forecast in degrees Celsius. We've got some warm weather coming to the east, so that cold air is going to blow out promptly here and be replaced by some incredibly warm air, especially for Missouri is going to see like 20 degrees Celsius above normal there for a moment. So that should be nice. And it's staying cold west of the Rockies there. And of course, you can practically see the hot, check it out, you can practically see the hot air coming out of Colorado. Look at that. West of the Rockies, it's cold. East of the Rockies, it's hot. As the port east of the Rockies is where all that hot air is blowing. Wow. A lot of hot air from charlatans spouting utter nonsense from Colorado. Not you, Scott McIntosh. Not you, Scott McIntosh. You're citing facts. I was talking about people overpaid millions of dollars per year to spout nonsense from Colorado. Next, our pressure and precipitation forecast. Looks like some strong storms will be here in about 3 days over Missouri, Illinois, and Indiana. So a low is going to rapidly form there around the Mississippi Valley. Let's take a look at snow totals since there is continued snow falling here. That is your accumulated positive snow depth change. All of these forecasts are the GFS 72-hour model, by the way, just looking at different parameters for the same model and time frame. And thanks for leaving a comment, Tinman1057. Congratulations on retirement down to 10 days, 8 hours, and 45 minutes. At least you're not counting the minutes. So next we're looking at precipitation type here, one of the great features of Windy.com's mobile app. If you haven't checked it out, check it out. Let's switch to new snow here. There is new snow for the next 3 days on the GFS model, which is actually what we just showed. And there is the Euro model. You can see quite similar there. Again, the Euro model. There's the GFS model. Let's continue on to our lightning mapper. It looks quite calm here for lightning over the North America in general there, some in Central America. And at the moment, no terrestrial strikes, according to lightningmaps.org. The Middle East there, seeing some thunderstorms. Also Western Africa. Next, our U.S. Doppler radar map. There's the full 50-state view. We'll focus on the lower 48 view. Doppler radar shows vertical motion in the air column. Shortwave radiation shows clouds and fog. That's the 3.9 nanometer radiation variety, part of the infrared light spectrum. And there is water vapor. And here comes your recap. Once again, Doppler radar. Was that too many facts for you? There is our interactive weather satellite showing clouds and fog, despite it being dark over most of the country. And there is the water vapor map, which shows all the water vapor, not just clouds and fog. It shows dry areas and wet areas. And hopefully that helps. Hopefully you're able to forecast your own weather. I can assure you that you are. And if you aren't, Smash News Network, least busted name in news, can. So thanks for tuning in, folks. Once again, congratulations on realizing the channel exists. We remain surprised that you've found the content. And we'll see you soon. In the meantime, may that solar wind be at your back. Don't forget to visit the links here and here and here.